For the differential equation, dy dx is xy, y is negative 2 when x is 1. Estimate the value of y when x is 3, using delta x is equal to 1. Check by solving the equation and computing y when x is 3. So once again, let's use a table to keep track of everything. So this would be our current point. And to begin with, of course, we have the point 1, negative 2. Then we're going to have delta x here, which is going to be 1 in this case. Then we'll have dy dx, which we know we compute using xy. Then we'll have delta y, and we can use that to get to the next point. So, delta x is x times y, which in this case will be negative 2. So delta y is these two multiplied together, dy dx delta x, so that's going to be negative 2. So our x goes up by 1, and our y goes down by 2. And so that becomes the current point now. Delta x is always 1. Dy dx is x times y, so that's negative 8. Delta y is negative 8, so x goes up by 1, y goes down by 8. So we can say y is negative 12 when x equals 3. So now let's look at solving the equation. So we've got dy dx is xy, so 1 over y dy is x dx, so separate and integrate. Ln y is going to be x squared over 2 plus a constant. So we can say that y is e to the x squared over 2 plus a constant. Now note here, that's e to the x squared over 2 multiplied by e to a constant, just using an index law. And of course this must be another constant, so we'll just call it a. And that's a fairly standard way of dealing with this type of thing. Now, we know that y is negative 2 when x is 1. So negative 2 is going to be a e to the half. So a is going to be negative 2 over e to the half, or negative 2 over root e. So we have negative 2 over root e, e to the x squared over 2 as our solution. So if x is equal to 3, y is going to be negative 2 over root e, e to the 9 over 2, or 4.5. And I've calculated that, and that's equal to negative 109 point something. So clearly we have a very big difference between our true value and our estimated value. Now, in this case, this discrepancy is all due to step length. We can see here the last few lines of a spreadsheet where I've used delta x is 0.01, and that gave us a y value when x is 3 of negative 106, nearly negative 107. So much, much closer to the true value.